So again, coming back to this Exergy balance equation. Okay, so since most of the times all we care about is sort of evaluating Exergy destruction and figuring out ways to minimize it. Okay, uh, the goal is not to find out. Goal is not to get zero Exergy destruction, right? Because that will be too costly from economic point of view. And as engineers, we're looking at economic solutions. But the goal is always to figure out where are the different ways uh, which are acting as the leak points, right? Where are we losing out energy to things that are not useful for us? That's not important for our eventual goal. So Exergy destruction is something that we always calculate for any given system, and it allows you to figure out in which component are you losing more Exergy, and then you can make a decision whether it's economic to reduce the Exergy in that particular component, or you should look at some other components, right? Always the idea would be, once you have a list of different components, let's say compressor, turbine, heat exchangers. Once you have a list of components and the order of Exergy destruction, then you can pick and make a choice where you want to start by reducing Exergy destruction and improve the overall efficiency and also the exergetic efficiency of the plant or the engine, right? Ways to increase the output. So okay, so since it's such an important thing, we'll talk about the different ways in which you can evaluate or calculate Exergy destruction. One way is obviously using the Exergy balance equation that we have here. So if you know the two states, right, you can calculate the Exergy change. You can also look at the heat transfer that's happening between the two states and the Exergy transfer associated with work transfer. And once you have all these terms known, you can easily calculate Exergy destruction by applying the Exergy balance. This is one way of doing it. Okay, depending on what's given in the question, you can maybe select this way to do it. There's another way to do it, and which comes from the entropy generation. So Exergy destruction is also equal to simply T naught times entropy generation, and T naught is the absolute temperature in Kelvin. Now, for this, all you need to do is to apply entropy balance and calculate entropy generation. Now, depending on the kind of information given in the question, you can pick up any of these two ways and go ahead and solve the problem. Usually the second method is simpler and faster, but some students are not very comfortable with using entropy balance. So it's up to you, whatever you use. But yeah, these are the two ways